Welcome to the third part of our tutorial, NFT ticket for your event. In the first two parts, we use quick note guides to create ERC1155 tokens on Polygon and Ethereum, and design, uploaded, and minted our NFTs on Polygon Mumbai network. In this third part, we will be creating a code in Node.js to interact with the contracts we have deployed. We will be minting from our code and using the setVerify and getVerify functions that we created in the previous video. Let's create a folder called Node Contract. Open a terminal and execute the following code. Now we will install the necessary dependencies. Create the following files from the terminal. We will put our private key in the secret file. This was explained in our previous tutorial, link in the description. At this point, we will create a new contract exactly like the one we made in the previous video. To do this, we just open a terminal in the folder where the contract is in, and run the command again, and the verification command. And we go to the Mumbai Polygon scan with the contract number that the migrate code gave us. Let's go to contract, then code, and scroll down to see the contract ABI section. Copy it, and then go to the ABI contract.json file and paste the entire content. Let's go back to the terminal in the folder of this tutorial. We will create our index.js file. We open it and start by importing the dependencies. With this dependency, you can have a local wallet that is necessary for signing transactions. This library allows us to read files from Node, which we need to read our secret phrase. This library allows us to communicate with the Ethereum network. There are other libraries like Ether.js that are also very common. We read our secret phrase with which we will sign transaction. We will use our favorite RPC. We created this in the previous video. We can say that an RPC is like an API service to effectively communicate with the blockchain. For us, the company that offers this service with the best performance is QuickNode. In addition to all the other services it offers, we talked about this in our video. Learn more about QuickNode, link in the description. We create our provider using the HD wallet package, which will give the Web3 library information about the network we will work on through the provider and the address of our local wallet, along with the authority to sign transactions. We import our API code. We declare the address of our smart contract, which is already available at this point. We declare a Web3 variable that will have the object through which we will access blockchain functions. We declare an account variable that will have our public address through a function of the Web3 library that we can now access from our variable. We define a variable, contract NFT, using the contract function from the Web3 library, which gives us access to the function of our smart contract. It receives as parameters the API structure, the contract address, and an object with the necessary information to interact with the contract. In our example, we only need to send the public address of our wallet. In the previous video, we used the deploy function of our smart contract directly on Polygon Scan. Now, we will do this process from Node, for which we need to declare an object with the information of our collection in the following way. we will create an asynchronous function to deploy our smart contract. In this function, we create a constant data that will save the result of sending the deployed ERC1155 transaction of our declared contract. The send function receives an object with the necessary information for the transaction. In this case, we need the address of our wallet, the gas limit, and the gas price. The parameters received by the deploy function are the parameters we already know. We do a console log if the transaction was successful, showing the transaction hash. We make sure to handle possible errors and place a call to the mint function that we will now create. We create the mint function. Here, we will iterate through our obj.collection object to access the mint function of the contract in a similar way to how we access the deploy function. But this time, we will do it for each NFT available in the collection. We invoke the deploy ERC1155 function, and now we will execute our index file. If there are no errors, we should have this result. Now, we will install the Phantom wallet to be able to view our minted NFT on our phone. Download the app from the Play Store or the App Store. Import your seed phrase. The Phantom wallet works by default with the Solana network, but for our purposes, we need to configure it to work on Polygon. To do this, we click on the icon in the upper left corner and now on Redeem Beta Code. Here we will enter the code "Let's go." Now we go to developer settings and select testnet mode. We click on Ethereum and then select Polygon Mumbai. In the second tab, we can see the minted NFTs. As a final step in this tutorial, we will access our getVerify and setVerify functions of our smart contract. We will do this provisionally from here to test that everything is correct, and in our next tutorial, we will be giving it some utility. Let's call the isVerify function with the index 0 and the ID 10. And we will call the setVerify function adding the value true as a parameter to change the state of the NFT. We will comment out the deploy function and place the isVerify setVerify isVerify function to see the change of the state in the terminal. If everything is correct, we will see how the isVerify function returns the false value by default. And in the second call, after invoking the setVerify function for the same NFT of ID 10, but with the true parameter, it will return the value true. Once you have completed this tutorial, you know how to interact with your smart contract using JavaScript. This can help us to verify the attendance at the event. Thank you for watching this video. See you in the next one.